Hi everyone, my name's Sam. I'm a senior here at the University of Wisconsin-Madison, and today I'd like to talk to you about improving our urban roundabout systems. In my first few presentations, I talked a lot about how roundabouts improve safety for all roadway users, but I've decided to narrow down my field of research to roundabouts located at busy city intersections. In doing so, I hope to address the issue of pedestrian safety. So just as a bit of a refresher, roundabouts are capable of reducing travel delay at intersections by allowing a constant flow of traffic around the central island. By limiting travel to a single circular direction, the number of conflict points in the intersection is reduced from 32 to 8. In doing so, this also removes the most serious conflict points that result in head-on and T-bone collisions. So in theory, roundabouts can improve both efficiency of travel as well as safety of roadway users. This is a feat which is very difficult to accomplish in intersection design. However, the largest issue remaining is the safety of pedestrians as they traverse the intersection. This presentation is going to explore some potential solutions to this issue, and by the end I hope to be able to make an informed decision on the best viable solution to protect pedestrians at busy urban roundabouts. So moving on to the problem can really be broken down into two core metrics, which are cities typically have a very high population density as well as a large traffic demand. And when these two metrics are combined, the result is a very dangerous environment for pedestrians attempting to cross streets. While typical signalized intersections combat this issue with crosswalk indicators, roundabouts located in or near busy cities face a serious problem, which is protecting pedestrians from a heavy flow of uninterrupted traffic. A study performed by the Governor's Highway Safety Association in 2018 determined that an estimated 6,227 pedestrians were killed in traffic accidents. This was an increase of more than 2,000 fatalities from a decade earlier. This increase has largely been credited to an increase in population and urbanization, as well as inattentive driving due to smartphones. All these factors make intersections far more dangerous than ever before, as more pedestrians and automobiles are on the road and paying far less attention to their surroundings. Fortunately, there are a few solutions that I've come across in my research that merit discussion in greater detail. So there are three possible solutions that I'll be exploring. The first of which is overhead walkways, then underground walkways, and crosswalk signalization. So each possibility will be evaluated based on the same core metrics, which are cost, constructability, maintenance, safety implications, environmental impact, and other social implications that the solution may have. It's important to also note that the cost of constructing a single-lane roundabout and a single-lane four-way intersection are, for all intents and purposes, equal, meaning that any extra cost assigned to each solution will be in addition to the cost of a traditional roundabout. So jumping into the first potential solution, the overhead walkway. I'm sure you're all getting tired of seeing the same roundabout in Shanghai, but this is still the best example that I've seen put into practice of this solution. For starters, the design is clearly safer for pedestrians as it completely removes them from the path of automobiles. However, it does have some serious drawbacks. The cost of constructing such a large overhead walkway would be significant. The extra materials required as well as the time of construction and labor would greatly increase the cost of this design. On top of that, the ramps to access the walkway need to be extended a notable distance away from the intersection. This is done to meet design criteria for the maximum allowable slope of ramps for wheelchair access. In terms of maintenance, there really isn't a notable increase so long as there isn't a need for escalators or other mechanical equipment. And the largest environmental impact due to this design would be increasing the area of impermeable surface. And this just means that there's more area for water to collect rather than seep into our groundwater system. And if not dealt with properly, this could lead to flooding should there be a significant storm. This design may also have some other unintended consequences that should be addressed, such as an increase in pedestrian traffic due to the intersection's touristy value. Anyone that hears about a walkway over a busy intersection in the city is going to be interested in seeing it firsthand. Also, the walkway is uncovered, which doesn't protect pedestrians against strong winds or rain. The second potential solution I explored was constructing underground pathways rather than above ground. The design shown in the images above was found on steamcommunity.com, which allows people to share ideas such as underground pedestrian pathways. Much like the overhead pathway, underground walkways are still much safer for pedestrians than traditional roundabouts, as the tunnels completely remove them from the path of automobiles. Similar to the first solution, however, this design has some drawbacks. The cost of constructing such a tunnel system would be significant, but not nearly as significant as an overhead walkway. Being completely underground, the only extra costs would come from excavation, installing a drainage system, and any extra materials. This would be far cheaper than constructing the support system and walkway in the overhead solution, and would take significantly less time. Also important, the ramps access to the walkway require much less space than the overhead walkway ramps. This allows the area impacted by construction to remain minimal. In terms of maintenance, it's essentially the same as the overhead walkway. The only factor that may affect this would be including any mechanical equipment such as escalators or lighting. Unlike the first solution, this design would have very little impact on the surrounding environment. The tunnel system being underground does not significantly increase the area of impermeable surface other than at the entranceways. However, being underground, there will need to be a proper drainage system installed to prevent water from pooling in the tunnels. This design may also have some unintended consequences. Being covered, the walkway provides great protection from rain and wind. However, this may cause the tunnels to become a source of shelter for homeless people and an area of concern for crime. As such, crime enforcement and surveillance in the area may need to be adjusted. This brings us to the third and final potential solution, which would be adding crosswalk signals to the roundabout. Right off the bat, a major issue with this solution is the violation of the core principles of a roundabout. By incorporating a safe walk period for pedestrians, there must be a stoppage in traffic flow. Drawing from the information I provided in the background, the driving force behind what makes roundabouts so special is their uninterrupted flow of traffic. So early on, this solution is facing an uphill battle. It does have some benefits that the other solutions don't provide, though. The largest is a very minimal increase to cost and construction. The only extra requirements for this design would be incorporating crosswalk signals into the intersection, which would cost significantly less than constructing either an overhead or underground walkway. Although less obvious, this solution would also improve pedestrian safety by providing them a safe time period rather than safe location to cross the street. This design also has essentially no additional environmental impact than constructing a typical roundabout would have. And aside from creating a stoppage in traffic flow, there are a few other drawbacks to this solution. Adding crosswalk indicators would require a large amount of electrical equipment and detection systems, all of which would require a fair amount of maintenance and calibration. Also, adding too much signal information to a complex intersection may confuse road users and actually increase the likelihood of accidents. All things considered, I feel it's safe to say that this is the worst of the three potential solutions discussed. With that being said, I will move on to my decision. The solution I feel most confident in is moving underground. Both from a safety and cost perspective, I feel this design is superior. The tunnel system can completely remove pedestrians from the path of automobiles, while leaving the above-ground traffic flow unaffected. This design also only requires a slight increase in construction cost and time, and has very little impact on the environment. The low space requirements also make it a viable solution for intersections that may not have much room to expand outwards. Overall, I felt this solution clearly stood out above the rest due to its simplicity and effectiveness at maintaining the core principles of a roundabout while improving upon pedestrian safety. So, in conclusion, I'd just like to take a minute to talk about some of the recent advancements in the transportation industry and where we're headed. Roundabouts have become a prominent design feature for intersections across the United States in recent years. However, as discussed here, there are still some areas to improve upon. The next generation of transportation system designers and engineers face a great challenge as new technologies such as smartphones and self-driving cars enter our industry. Methods to maintain safety which worked in the past may become outdated, which places the burden of producing new creative ideas to keep our roadways safe on us. I'd like to thank you all for your time and a wonderful semester, and I'm now open to any questions you have.